Hey guys, so in order to start balancing a chemical reaction, like this one, Mg plus N2 reacts to form Mg3N2, you're first going to draw a line down the middle and under the reaction arrow like this. On either side of the line, you're going to write down how many atoms of each element you have. So on the left side, right now I have one magnesium atom, so I'm going to write down 1 Mg to mean one magnesium atom. I'm then going to write down 2 nitrogens because I have 2 nitrogen atoms on this side right now. So 2N. On the right side here, I have 3 magnesium atoms and 2 nitrogen atoms. So I'm going to write down 3 Mg for my 3 magnesiums and my 2N for my 2 nitrogens. And now I'm going to compare and see if I have the same amount. So I have the same amount of nitrogen on both sides, which means nitrogen's happy. I'm not going to do anything with nitrogen because I have 2 nitrogens on the left side of the reaction and I've got 2 nitrogens on the right side. That means I'm not creating and I'm not destroying any nitrogens. So that's good. But I have 1 magnesium and I have 3 magnesiums on the right side. That means I start with 1 magnesium atom and I'm going into 3 magnesium atoms. I can't create those magnesium atoms out of thin air. I've got to have these numbers be equal on either side of the line. The only thing I can do to make sure that the numbers are the same is change the coefficients. The coefficients are the numbers that are in front of each type of molecule or particle in the reaction. So I can put a number in front of here, I can put a number in front of here, I can put a number in front of here. I cannot change the small numbers here. If I change the small numbers here, I have a different molecule, and therefore it's a completely different reaction. But I can change the big numbers out front, because that's just how many molecules are reacting. I'm not going to change this number, because if I have one N2 molecule, that's giving me 2 N's, I'm already happy. I don't have to change the number of N's. In the same way, I'm not going to change the number in front of this, because if I have more than one of these Mg3N2s, that's going to give me a different number of nitrogens, because that's going to affect the whole molecule. Instead, what I'm going to do is I'm going to come over here, and I'm going to put a 3 as the coefficient in front of that Mg. If I have a 3 in front of there, that means I have 3 magnesium molecules. That means I have 3 right here. So this goes from 1 magnesium into 3 magnesium atoms. Now my magnesium is happy because I have 3 magnesiums on the left side and 3 magnesiums on the right side. I have my nitrogens happy as well, so this is now a balanced chemical reaction. What this is saying is that 3 magnesium atoms react with 1 N2 molecule to form 1 Mg3N2 molecule, or 1 magnesium nitrate or nitride molecule, as we know it's called now. Okay, so let's try another example. In this reaction, we have Fe, which is iron metal, reacting with H2O, which is water, to form Fe3O4, or iron oxide. This is a black powder, plus H2, which is hydrogen gas. So to balance this reaction, we're again going to draw a straight line down the middle under the arrow. And we're going to write out how many atoms of each element we have on each side. So on the left side, we currently have just 1 iron atom. So we're going to write 1 Fe. We have 2 hydrogen atoms from the water. So we're going to write 2H. And we only have 1 oxygen here because there's no number next to the O, so it's implied that it's 1. So we have 1 oxygen atom. On the right side, we have 3 irons. We have 3 Fe's. So we're going to write 3 Fe, or 3 iron. We have 4 oxygens, so we're going to write 4O. And I'm going to write that down here just so that O is on the same line as the other O. That's going to make it a little bit easier to compare next time. And lastly, we have 2 hydrogens. So I'm going to put 2H right in the middle. And again, this is right next to the other H, the other hydrogen. So it's going to be easier to compare. Now, right off the bat, I can see that we have the same number of hydrogens on both sides. So I'm not going to try and change anything with hydrogen just yet. We have different numbers of irons though. We have 1 iron atom here, and we have 3 iron atoms here. And down here, we have 1 oxygen atom and 4 oxygen atoms. So we need to make these all the same number. Now to begin with, the easiest thing to do will probably be to get this iron into 3, because we just have iron in this form where it's individual atoms. So if I want 3 irons here, I can just change my coefficient. Remember, you can only change the coefficients, the front number. I'm going to change it into 3. Now I have 3 iron atoms reacting. That's going to change the number of iron atoms I have on this side to 3. Now my irons are happy. I have 3 irons on the left side and 3 irons on the right side. I have 2 hydrogen atoms on the left side. I have 2 hydrogens on the right side. The only thing I need to fix now is oxygen. Since I have 1 oxygen atom on this side and 4 oxygen atoms on this side, I'm going to deal with this side first because I have less oxygens. Now if I want 4 oxygens on this side and I get 1 oxygen atom in every H2O molecule, I'm going to write a 4 as the coefficient out front. If I now have 4 water molecules, I'm going to have 4 oxygen atoms. So I can change the number of oxygens into 4. Now I didn't just change the oxygen though, because I said I have 4 of the entire water molecule. The water molecule also has hydrogen atoms in it. Each water molecule has 2 hydrogen atoms in it. If I have 4 of these molecules, then I have 4 groups of 2 hydrogen atom each. So the total amount of hydrogen atoms will be 4 times 2. That gets us 8 hydrogens total on the left side. Okay, now I have 3 irons. I have 8 hydrogens, and I have 4 oxygens. So now iron and oxygen are balanced, but hydrogen, I need to do something to fix this. It was balanced, but it's not anymore. The first molecule here, iron oxide, it doesn't have any hydrogens in it. I'm not going to touch it because I already finished balancing iron and oxygen. Here, my H2 molecule, I'm going to have to balance that. I'm going to have to do something to that to get 8. In each of these H2 molecules, I have 2 hydrogen atoms, and I need 8 hydrogen atoms in total. So 2 times what will give me 8 on this side? 2 times 4 is 8. So I'm going to write a 4 in front of my H2 molecule. That means that I'm producing 4 of these H2 molecules. Each H2 molecule has 2 hydrogens. If I have 4 of them, then I'm going to have 8 hydrogen atoms in total. And now I'm balanced. I have 3 irons, I have 8 hydrogens, and I have 4 oxygens. So this is my completed reaction. 3 iron atoms react with 4 water molecules to form 1 iron oxide molecule and 4 hydrogen gas molecules. Okay, now let's do one more example. So we have C3H8. That molecule is actually propane, reacting with oxygen gas to form carbon dioxide and water. This is the burning of propane. So to balance this, we're going to start by drawing our vertical line under the reaction arrow and listing out the number of atoms of each element that we have. So on the left side, we have 3 carbons. We have no other carbons, so I'm going to put 3C on the left side. We have 8 hydrogens and no other hydrogens. So I'm going to put 8H on the left side. I have 2 oxygens and no other O's, so I'm going to put 2O. On the right side, I have 1 carbon. I'm going to line it up with this C so it's easier to compare later. 1C. For hydrogens, I'm going to skip this oxygen for now. For hydrogens, I'm going to put 2H because that's the only hydrogen I have right now in the water molecule. So 2H. And I put the H next so that it was lining up with the H on the other side, so it's easier to compare later. Now I'll do oxygens. So I have 2 oxygens from the carbon dioxide, and I have 1 oxygen from the water molecule. So in total, I have 3 oxygens. So I'll put 3O on the right side. Okay, none of this is balanced right now. None of these 3 molecules. So to start with, I'm going to balance the top. Generally, when you have oxygen, generally speaking, your rule should be you try and balance oxygen last because it's going to give you the most problems if you try and balance it at the beginning in general. So if I try and balance carbon first, remember I can only put a new number in front. These are called coefficients if you put a number out front of a molecule. So if I have 3 carbons and I have 1 carbon on the right side, to give myself 3 carbons on the right side, I'm going to add the coefficient 3 in front of CO2. That's now going to give me 3 carbons. So I'll replace this with 3 carbons. And it also changed the amount of oxygen I have because I have 3 molecules of carbon dioxide. Each molecule has 2 oxygens. So 3 molecules of 2 oxygens each, 3 times 2 will get me 6 oxygens in total. And I still have this extra oxygen on the water molecule, so that will give me 7 oxygens. Okay, I have carbons balanced. Now I'm going to go on to hydrogens because again, I'm not going to worry about oxygen for now. So I have 8 hydrogens on this side and I have 2 on this side. If I want to get to 8 hydrogens on this side, I'm going to have to modify the amount of water molecules I have. So if I want 8 and each molecule gives me 2 hydrogen atoms, I'm going to put a 4 as my coefficient here. That will give me 4 molecules. Each one of those has 2 hydrogen atoms. 4 times 2 will give me 8 hydrogen atoms here. That didn't just change hydrogen though, because this 4 applies to the entire molecule. So now I have 4 oxygens coming from the water. Over here, I had 3 times 2 equals 6 oxygens. Then over here, it's giving me 4 oxygens. 6 plus 4 oxygens equals 10. So I'm actually going to erase this in front of the O. And I'm going to put our new number 10 oxygens in total, 10 O's. Okay, carbons are balanced, hydrogens are balanced, but on the left side we only have 2 oxygens, on the right side we have 10. So in order to get 10 oxygens, I'm going to put a coefficient 5 in front of this O2. Now I have 5 molecules of O2. Each molecule has 2 oxygens. That will give me 5 times 2 is 10 oxygens. And that's our final answer now. For every 1 molecule of propane that reacts, we have 5 oxygen molecules that burn with it. These react to form 3 molecules of carbon dioxide and 4 molecules of water vapor.